Tech Nuggets, IPv4 routing. So today we're going to talk about routing principles. How do data files get turned into packets? Where do they go? How do they get there? How do all those little packets get from one end to the network to the other? It's a confusing kind of discussion. We're going to go over some of the basics of it. I've got some diagrams that we're going to talk about with kind of super techie terms, and we'll talk about how that works. I'll do an additional video where we'll go back and we'll take off some of the, we'll add some technical detail to the diagrams to get a little more down into the nitty-gritty of how that actually works. But to start with, we're just going to have a basic discussion of how things get turned into packets and move from one end of the network to the other. First thing to understand is that data on any device has to be turned into these things called packets. And if you think of it as your PC has a block of salt that you want to send to the other end of the network, let's say to the printer, you want to print your block of salt, you have to break it down first into a bunch of teeny tiny little things like grains of salt, and you send the grains of salt over the network, and the printer on the other end will reassemble it all back exactly the way it was and then print the block of salt. So packets are pretty small. They're 1,500 bytes or so. They're very small. So if you were to take your calculator and take your, images that come down off of social media or something like that, and they're a couple of gigs, and divide them by 1,500 bytes, there are a lot of packets, even in a small image. Each one of those packets gets sent over the network, and the remote device will reassemble them back into something. So when your device pulls images off of social media or a website or Wikipedia, it reassembles them all and shows it back to you as a whole. Each packet, each individual packet, which there are zillions of them, has a destination address and a source address. So where am I going? Where am I sending these packets to? And who am I that's sending them? Now, there's a ton of other information in those packets, but in terms of addresses and things like that, that's not specifically part of the data. We call that information headers, packet headers. We're not going to get too much more into what's in a packet header, but there'll be other fields in there that are very useful and interesting as we get into advanced topics. So you'll hear that come up as we go more. So routing packets to the destination, and some of this slide is basically defining some terms because they get a little nebulous and we want to make sure that all the terms get laid out. So network routing is the process of using globally unique addresses to transfer packets from one place to another. Often the packets will traverse many intermediate networks. Again, I'll go back to talking about traceroute, which we saw in previous labs, where you might have 15 or 20 hops. Those are small little networks in between different routers before it gets from you to wherever it's going. And again, that's why in that lab we went over sort of the basics of showing that tool. This video in this lab is about explaining some of what am I seeing in traceroute, what's it mean. And all the routing that goes on is what we're going to talk about here. All right, so we're going to lay out some assumptions so that when we look at the diagrams, everybody will kind of have an idea of what we're talking about. So our workstation, Kelly, has a globally unique IP address that's been statically assigned. So the network administrator came, put IP address on it. We also know the IP address of the local gateway, Chris. So again, another IP address that gets put in as a default gateway or a local gateway. And Kelly also knows the IP address of the local printer, Zach. So that way, Kelly's got everything programmed in it automatically. There's no auto discovery. It's not magic. Somebody came to the machine and programmed it all in and knew the IP. Maybe they brought it on a piece of paper with them or something like that and put it in the machine. So we're starting with several known things. The other thing that all three of these devices will know is their subnet mask. So they will all be in the same subnet. And if you've watched the subnet videos, you'll know what subnet masks mean. You'll be able to look at the IP addresses at the bottom of the slide here. They're all a /24, which means they're all in the same subnet together. So they should be able to directly speak with each other. All right, situation one. Kelly needs to print a document. Kelly knows the IP address of the printer, Zach, like we just talked about. Kelly's able to take the print job, turn it into packets, and can directly send it over the local network to Zach. Zach receives the packets and reassembles them back into a print job and can start printing. This sounds very simple because it is pretty simple. It's your standard local LAN discussion. And I drew a diagram of it here. We'll talk a little about the diagram. You can see that Kelly and Zach are plugged into a mini switch together, and Chris is also plugged into the same mini switch, and the circle kind of represents the LAN environment that they're in. Mini switches can be anything from a small 4-port device that you would buy at Staples or Micro Center or online on Amazon or something like that. And the circle represents that network is usually pretty small. They're usually smaller networks. So in terms of Kelly, currently we would probably be using Ethernet switches, which means about 100 meters is about as far as you're going to get from that mini switch with a physical cable. So Kelly and Zach can only be about 200 meters apart, because it's 100 meters from Kelly to the mini switch, and it's another 100 meters from the mini switch to Zach. So that's the maximum distance they could be apart. 200 meters is not that far. It's about 2 football fields, something like that. If you're in imperial units, that's a local LAN kind of discussion. Chris is also involved in this, and we'll talk about Chris in our second situation, but suffice to say, this is a local LAN environment. Kelly can use the globally unique address to talk to Zach to send the print job, but in this case, we're all on the same LAN. There are probably local LAN protocols that we could use, but our globally unique IP addresses will work just fine as well. Routing. This is where it gets a little more fun. Situation 2. Kelly needs to view a web page on the corporate web server. We're going to assume Kelly has the IP address of the corporate web server. Kelly wrote it down, brought it with him to the workstation, and was able to program it into a web browser, typed it right in, no big deal. The corporate web server in this case is not on Kelly's local network. Kelly knows from the programming we did earlier about the local or default gateway that if I want out of this network, I gotta send my packets to Chris, because Chris is my gateway out of here. Kind of like the bouncer at the door at the bar, Chris is the person passing messages back and forth from the local network to anything outside the local network. Chris has a local connection to our network and to several other networks, one of which will lead to the corporate web server eventually. Chris will take those packets and retransmit them on the remote non-Kelly network that's headed towards the corporate web server. I've got a diagram, so if all those words get kind of confusing, it's okay, it is kind of confusing. In this diagram, we can see Kelly and Chris are on the same network. So Kelly can directly talk to Chris. And remember, each one of our packets comes with a source address, which is Kelly, and a destination address, which will be corporate web server. So Kelly will send those packets to Chris. Chris will look at the destination and say, I need to send that on to somebody else that can talk to the corporate web server because I can't. But Chris has a default default gateway as well, which is John. So Chris knows, if I don't know what to do with this, I send it to John. So Chris will send it to John. John will look at it and say, oh, hey, I'm in a network with the corporate web server. I can talk directly to that person. And it will send the packet onto the corporate web server because John and the corporate web server are on the same LAN together. And John will send the packet directly to the corporate web server. And when we do it in reverse, it'll work the same way. Any response that comes from the corporate web server will get a destination address of Kelly, a source address of corporate web server, and the packet will be sent to John as the default gateway out of that network. And John will get the packet and look at it and say, ooh, that needs to go on to Chris because Kelly is over on Chris's network. And John will send it to Chris. Chris will look at it and say, oh yeah, I can talk to Kelly directly, and we'll send it on to Kelly. And therefore the packets can go back and forth. This chain of little bubbles can get quite long. As I said, when you look at your trace route and there's 15, 16, 17 hops, each one of those hops is one of these little bubbles that's going on with a router talking to another router, talking to another router. We'll go on in these two examples, and I'll substitute the words Kelly, Chris, and John for IP addresses, and we'll make it a little more complex where we talk about route tables. How does Chris exactly make that decision of where to send it? What if there's multiple places I could send it, and Chris has 4 or 5 places he could send it to? How does that decision get made? Make sure you check out our next video, and we'll go over all that stuff with a lot more detail on the technical end.